This question asks you to explore some properties of the family of curves y is x cubed plus x squared plus b, where x is real and a and b are real parameters. First, consider the case where a is 3. Question A. By systematically varying the value of b or otherwise, find the two values of b such that the curve y is x cubed plus 3x squared plus b has exactly two x-axis intercepts. 2 marks. And question B. Write down the set of values of b such that the curve y is x cubed plus 3x squared plus b. The same curve has exactly I1 x-axis intercept 1 mark and II 3 x-axis intercept 1 mark. So we should consider the next function. Y is x cubed plus 3x squared plus b, and we need the number of x-axis intercepts, or it's actually the number of roots depending on the values of b. And what is the graph of such a polynomial function? It looks like this. Y. If we consider that x tends to plus or minus infinity, or when x is very large, positive or negative, we take into account only this term corresponding to the largest power of x. Why? Because other terms will be much less. And when x is very large by positive, you can see that y will be also very large and positive. It means that this tail goes up. And when x is very large and negative, y will be also very large and negative. So this tail goes down. And if we consider stationary points or points with zero gradient or candidates to be turning points, we should do what? Consider derivative, and you can see that derivative will be polynomial degree of 2, and when you equate it to 0, you will get what? 2 roots. So it means there will be two stationary points, but according to these tails, there must be one local maximum and one local minimum. And if x-axis is somewhere here, you can see that there will be only one x-axis intercept or only one root. If x-axis is somewhere here, you can see in between maximum and minimum there are what? 1, 2, 3 roots. When x-axis passes through this minimum point, you can see 1, 2, there are 2 zeros. And also when it passes through this maximum point, also there will be 2 roots. And when x-axis is somewhere here, you can see that there will be only 1 root. So definitely we need what? Coordinates of these points of zero gradient, local maximum and local minimum. How to find them? We should consider what? Derivative. And derivative becomes what? 3x squared plus 6x, and equating it to 0, we get the next 3x. X plus 2 is 0, so x is 0, x is negative 2. And it's not necessary to check whether it's maximum or minimum by considering second derivative. Why? Because definitely point to the left is maximum, to the right minimum. So negative 2 is to the left, so it will be this point, 0 is this point. And to find y coordinates, we just substitute 0 for x. You can see it's b, so this point of local minimum is 0b, and substituting negative 2 for x, we get negative 8 plus 12 plus b. So 4 plus b, it's a point of the local maximum. And for question A, we need what? Exactly 2. Exactly 2. Exactly 2 is when x-axis passes through this point. And what does it mean? It means that what is x-axis? It's when y is 0, so y coordinate of this point must be 0, and y coordinate is b, so b should be 0. Or when x-axis passes through this point, and it's when y coordinate of this point is also 0. So to get exactly 2 roots or x-axis intercepts, we need b to be 0 or b to be negative 4. And for bi, we need what? Exactly 1. exactly 1, it's when x-axis and x-axis it's y is 0, so y x-axis it's horizontal line with equation y is 0, and to be below this point with y coordinate which is equal to b, so 0 must be less than b, or from the other hand this point must be above the x-axis, so y coordinate which is b must be greater than 0. So b and or actually not and or when x-axis is above x-axis it's 0 is greater than 4 plus b, or when this point 4 plus b is below x-axis, it means y coordinate 4 plus b must be less than 0, and hence we get that hence b is greater than 0 or b is less than negative 4. And for I we need what? Exactly 3. Exactly 3, it's when x-axis is in between and x-axis is y is 0, so 0 must be greater than b, and here it's and, it's at the same time 0 must be less than 4 plus b, or this point must be below x-axis, so b must be less, and this point must be above the x-axis, so 4 plus b must be greater than 0, but it's at the same time, it's and. So we get b is less than 0, and at the same time b must be greater than negative 4. So solution is b is greater than negative 4 and less than 0. Next, now consider the case where a is negative 3. C. Write down the values of b such that the curve y is x cubed minus 3x squared plus b has exactly I2, II1, III3 x-axis intercepts, and 1 mark for each question. And actually everything is absolutely similar. So now derivative becomes what? 3x squared minus 6x, and it should be 0, so 3x, x minus 2 is 0, x is 0, x is 2, so now 0 is to the left and 2 is to the right, so at x is 0 there will be maximum, at x is 2 there will be minimum, and when x is 0 we can see that y is b, and for x is 2 we get negative 4 plus b. And absolutely similarly for I2, exactly 2 when negative 4 plus b lies on the x-axis, it means it is equal to 0, so when b is 4, or when x-axis passes through 0b, so or b is 0. I1 x-axis 1, it's when x-axis, which is 0 below negative 4 plus b, or this point is above x-axis, negative 4 plus b is greater than 0, so b is what? Greater than 4, or x-axis, which is 0, is above 0b, so b is less than 0. And 3, exactly 3, it's when x-axis, which is 0 above negative 4 plus b, so it's greater than negative 4 plus b, and at the same time below this point 0b, or when point negative 4 plus b, y coordinate is less than 0 to be below x-axis and 0b to be above x-axis, b must be greater than 0 and at the same time. So b is greater than 0 and at the same time b is what? Less than 4. So solution is b is greater than 0 and less than 4. And the next. For the following parts of this question, consider the curve y is x cubed plus ax squared plus b d. Consider the case where the curve has exactly 3 x-axis intercepts. State whether each point of zero gradient is located above or below the x-axis. 1 mark. Definitely to have 3 zeros, so 3 x-axis intercepts. One point is above, another is below the x-axis. DE shows that the curve has a point of zero gradient at P is 0b and a point of zero gradient at Q is negative 2/3 a 4 over 27 a cube plus b 5 marks. So points of zero gradient, it's our local maximum minimum points. So we need for what again, consider derivative, which is 3x squared plus what 2ax, and it is 0, so it becomes x. 3x plus 2a is 0, so x is 0 and x is negative 2a over 3. And let it be x1, x2, so y1 is what? When x is 0, it's just b, and y2 is substituting negative 2 over 3 times a for x, we get what? Negative 8a cubed over 27 plus a for a squared over 9 plus b is 4 over 9, it's what? 12 over 27, 12 minus 8 is 4, so 4a cubed over 27 plus b is required. So you can see that points of zero, hence points of zero gradient are p, 0, b, and q, negative 2a over 3 for a cubed over 27 plus b as required. F. Consider the points P and Q for A is greater than 0 and B is greater than 0. I. Find an expression for the second derivative and hence determine whether each point is a local maximum or a local minimum. 3 marks. And actually find out whether it's maximum or minimum, it's not necessary to find second derivative because we know that it looks like this, and for the less value of x, and when a is greater than 0, this point will be less, so it will be this point and this will be here. And let's check by considering. Let's check. We need what? Second derivative, and second derivative is what? It's 6x plus 2a, and second derivative at 0 is 2a is what? Greater than 0 for a is greater than 0, and second derivative at negative 2 over a is what? Negative or 6 multiplied by negative 2a over 3 plus 2a, which is what? Negative 4 plus 2 negative 2a, which is what? Less than 0, for a is greater than 0, hence it's hence 0 it's p, hence at p there is a local, since second derivative greater, local minimum, and at q, which is negative 2a over 3 and 4a cubed over 27 plus b, there is a local maximum point. So it's fi and fii. Determine whether each point is located above or below the x-axis. 1 mark. Since a is greater than 0 and b is greater than 0, you can see that b is greater than 0, hence p 0b is above the x-axis, and since a is greater than 0 and b is greater than 0, 4a cubed over 27 plus b is greater than 0, hence q is also above the x-axis. Next, G. Consider the points P and Q for A is less than 0 and B is greater than 0, I. State whether P is a local maximum or local minimum and whether it's above or below the x-axis. 1 mark. So we need P only, it's 0B, and you can see that P is 0, negative 2a over 3, and when A is negative 2a over 3, it will be positive and greater than 0, so Q will be to the right, so P will be maximum, Q will be minimum. But we need show it using the second derivative. So P or 0b and second derivative at 0, and second derivative it's again 6x plus 2a. 6 times 0 plus 2a will be what? Negative or less than 0, for a is negative, and it implies that at P, or P is point P is a local maximum point, and since B is greater than 0, P is above the x-axis. II. State the condition on A and B that determines that Q is below the x-axis. 1 mark. Below Q has y coordinate for a cubed over 27 plus b. To be below the x-axis, it must be less than 0, y coordinate must be less than 0, and that's all for 1 mark. And finally H proves that if 4a cubed b plus 27b squared is less than 0, then the curve y is x cubed plus x squared plus b has exactly 3 x-axis intercepts. 5 marks. So let's consider this inequality, and you can see that we can factor out b, and it becomes 4a cubed plus 27b is less than 0, and product can be negative when this factor, when b is greater than 0 and 4a cubed plus 27b is less than 0, or b is less and this is greater, or b is less than 0 and 4a cubed plus 27b is greater than 0. For this, when b is greater than 0, you can see that a is what a cubed is negative 27b over 4, but b is positive, so a cubed is negative, so a is negative. So we get what? B is greater than 0, a is less than 0, and 4a cubed plus 27b is less than 0. It's actually answer for the previous GII, and its condition shows that Q is below x-axis. So P, there are 2 points, P with coordinate 0, B, and Q is negative 2a over 3 for a cube over 27 plus b. And so when b is 0, p is above the x-axis, and using the answer for GII, this it was a question for what, that Q is below the x-axis. So it looks like this: P, Q, and therefore there are exactly 3 x-axis intercepts. And now we can consider, we should consider this: when b is negative and for a cubed plus 27b is positive, so this for a cubed is greater than negative 27b, but if b is negative, it becomes that 4a cubed is greater than 0 for b is negative, because it's negative with minus positive, a cubed positive, hence a is positive. So b is negative, a is positive. And let's consider our points. So p it's 0b, q it's negative 2a over 3, and 4a cubed over 27 plus b. And actually you can see that a is positive, so q will be to the left, p will be to the right, but so q is maximum, p is minimum, but let's use the second derivative. Using the second derivative, and you remember that second derivative is what? It's 6x plus 2a. So second derivative at 0, second derivative at 0, it's what? 2a, and it's greater than 0. For a is for a is greater than 0, hence P is minimal, it's local minimum, and hence Q is a local maximum point. Local maximum Q P. And now when it shows that P is below the x-axis and Q is above, to get or to prove that there are 3 roots as required. And how to prove that? How to prove that B is what? 0 B, and here B is what is less than 0, so definitely since B is less than 0, P is below the x-axis. And now when it shows that Q is above, Q is above, what does it mean? It's y coordinate for a cube plus 27 plus b should be greater than 0, but we start with what? With this, and we can see that since 4 cubed plus 27b, since 4a cubed plus 27b is greater than 0, and it implies that y coordinate of b is greater than 0. So you can see it's quite clear that for a cubed over 27 plus b also will be greater than 0, hence Q is above the x-axis. It's you may just divide by 27, so you can see 4 over 27 a cubed plus b will be also greater than 0 over 27, and if we divide or multiply by positive number, we keep the same inequality sign. If you divide by negative or multiply by negative number, you should flip a sign, and hence it will be this. And therefore, or since P is above and not P, Q, since Q is above, and P is below the x-axis, there are exactly 3 x-axis intercepts as required. And that's all for this question.